Good evening and welcome to Word Problems, Volume 2, actually Volume like 20. But these are factoring word problems, which means you need to know how to factor in order to solve them. Remember that the steps for factoring are first, set equal to 0. Then second, simplify each side. I'll kind of put that as a little separate step. Simplify. Then 3 is to factor. And then 4 would be to set each factor equal to 0. So, anyway, these word problems are going to be a little bit more complicated than the ones we did before. Same 4 steps. You need a let statement and or a sketch. You're going to add to that we need units on the sketch. Number 2, we need an equation. Number 3, we need steps to find the solution. And number 4, we need the answer in a complete sentence. I'm going to add to this, all work must be shown on separate paper if you're doing this on your own. So like the homework we did, 2 nights ago. Okay, number 1. A photograph is 3 centimeters longer than it is wide. Hey, we have a photograph. I'm going to put a little box here. We're going to call that a photo. If a 4 centimeter border is added to all sides, then the total area will be 460 square centimeters. What are the dimensions of the photograph itself? Well, it wants to know the dimensions of the photograph, and it says that it's 3 centimeters longer than it is wide. So what that tells me is that we're going to have a width, and then we're going to have a width plus 3 for our length. That right there is enough information about the photograph itself. Okay, if you have a separate color, you use it. If you have a separate type of pen or pencil, use it. Otherwise, just kind of shade in a different color. I'm going to draw a border around this thing. I'm going to make it a little bit bigger than is needed. So we have a photograph right here. Here's a photo with a person inside. And then we're drawing a border, and it's a border that has a pattern or something. It's going to make the photo look all pretty and stuff. And suddenly it can become confusing about what's what. What's the W? What's the W plus 3? So I'm actually going to scoot this W plus 3 kind of over just a little bit so that we know that the W plus 3 is actually the length and the W is the width. Then, hopefully you didn't use a pen. If you did, I'm sorry. But what I'm going to do is I'm going to erase some of this border here. And I'm going to say that now this width right here, this little piece right there, that's 4 centimeters. That's 4 centimeters. In fact, it's 4 centimeters everywhere. This is 4 centimeters. This is 4 centimeters. And this is 4 centimeters. Look at how we have a picture to kind of help us here. Okay, then it says if a 4 centimeter border is added to all sides. Well, we just did that. This is how we draw a border, and this is what I'm going to want to see on all your things. If you choose to use a photo, a sketch, you're going to want to have this border present all over the place. Okay, so we're going to add this border, and then next it says the total area is 460 square centimeters. Well, what that means is the area of the entire thing. Look at this blue shading. This is going to be the whole thing. So I need to basically know what the length and width is of the whole thing. I need this and this because length times width is equal to area. Well, let's look at the longer one first. Let's look at the W plus 3. So I'm going to kind of scooch out here and say that I know that from here to here, this little piece right here, that is W plus 3 because it was W plus 3 on the other picture. But I also know that this is 4 and this is 4 because that's the width of the border. So my total length is actually W plus 3 plus 4 plus 4, or W plus 11. Then I'm going to go to the total width. I'm going to do that down here. I'm going to say, well, this piece right here, this is W. And then this piece here, that is 4, and this piece here is 4. This is actually W plus 8. And then I know the length times the width, W plus 8 times W plus 11 is equal to 460. That's what we want to solve. Well, we're going to FOIL that out. W squared plus 8W plus 11W is plus 19W plus 88 equals 460. Well, we want to set it equal to 0, so I'm going to subtract 88 from both sides. Subtract 460 from both sides, minus 460 minus 460. And I have W squared plus 19W 460 minus 88 is 372 negative 372 equals 0. Then we have to break up 372. I need two numbers that multiply to 372 but add to 19. So let's play our factor tree game. 372 is divisible by 3. It's divisible by 2, which means it's divisible by 6. So if I can break it up into 6 and something, 6 and, let's see, that'd be 6 and 50, nope, 62. Let's see, 6 and, yep, 6 and 62. Okay, well that's not good enough. Maybe move a 2 over to 6. So I know it's going to be 12 and 31. Ooh, there we go. 31 is prime. That's a good one. We have a prime factor because we can't do anything with that. 31 and 12 differ by 9, so this is going to be W and W. I have 31 and 12, which gives me, I should want plus 31, oops, plus 31 and minus 12. Okay, that tells me that W is equal to negative 31 or W is equal to 12. Well, W can't be negative 31, so W equals 12. Then we go back and we say, it says, what are the dimensions of the photograph itself? Well, the photograph was a W by W plus 3. So I want to plug the 12 in, and I can say the dimensions are, that would be 12 centimeters by 15 centimeters. And that's my solution. So, step by step, you're going to want to rewatch these examples several more times, just to kind of be clear on them. This class notes page is going to include all the different types that we're going to do, and we're going to practice with 1, 2, 3, 4 of them, just 4. Okay. So let's keep going. What are we at? 6, 7 minutes now. Sorry. The outer dimensions of a picture frame are 14 by 18. The area of the picture that is exposed is 192. What is the width of the frame? Okay, I see picture frame. You're going to do one of these pictures. You're going to do something like this, and then you're going to go inside, and you're going to do another one. This is kind of the image of your border problems. And that's what these are called. I want you to go back up and see, ooh, got border problems. I want you to write somewhere up here, border problems. That's what these are called. I'm going to be looking for this when I check your notes. Do you have border problems written? And if you're listening to this, don't tell anyone who's not, or asks to see yours. Okay, just leave it. I'm looking for border problems. The outer dimensions of a picture frame are 14 by 18. Outer dimensions means outside. The area of the picture that is exposed is 192 square inches. So I can write that inside. Woohoo. We've actually covered most of the stuff here. Then it says, what is the width of the frame? What does that mean? Well, guess what? I'm going to switch colors. We're going to make it a little orange. I'm going to zoom in like crazy, and at least as much as I can. I'm going to say that means this thing. I'm actually going to call that X. And I'm going to call this X. And yeah, I'm going to write it 4 times. I'm going to call this X. I'm going to call that X. That's what it means by the width of the frame. It doesn't mean this thing. That's the width. That's like the outside width. We call this outside width. We call the other one outside length. But when we say the width of the frame, that's this thing here. That is width of frame. So, I'm going to use a let statement. Let x equal the width of the frame in inches. You don't have to put this because you already have it on the picture, but I'm going to put this anyway so you can look back and see what the heck we were calling x. Okay, I like this orange color, but we're going to switch to a different color because now I'm going to describe the inside dimensions. Okay, this is going to be kind of critical here. If this whole thing is 14, and this is x, and this is x, let's move the 14 out of the way here. Come on, you're going to move up there. What is this middle piece here? Meaning, what is this piece right here, which is the same as this piece right here? Well, that'd be the total minus the 2 parts. That is 14 minus 2x. Once you get the 14 minus 2x, the other one's easy. This piece here, this would have to be, the outside was 18 for that one, so this is 18 minus 2x. Very common mistake that people do is they'll say it's 18 minus x, but there's 2 sides to the border. Border goes on all 4 sides. So we got 18 minus 2x. So this is our equation right here. This times this is going to be equal to that. So 14 minus 2x times 18 minus 2x is equal to 192. If you're clever, you could take a 2 out of both of those and divide both sides, so your foiling is going to be easier. Or you could FOIL it now. I'm going to keep things just a little bit easier for us right now, just because I know we're working up to this. So I'm just going to FOIL this right now. 14 times 18. I have poor calculators, so we're going to use this old-fashioned method of multiplying. 14 times 18, double check. Yes, 152. I'm not faking this, guys. I actually don't have a calculator next to me, and I haven't done this in a year, so I'm right where you are in not knowing the answer before I start these. Okay, this would be minus 28x minus 36x, and then plus 4x squared is equal to 192. Let me kind of erase that because it's a little messy. Let's switch the order. 4x squared minus, this is going to be 64x plus 152 is equal to 192. Now, any time here, you can divide both sides by a 2 or even by a 4, I think. But let's just subtract the 192 first here. I have 4x squared minus 64x. That'd be minus 40 is equal to 0. I'm going to go ahead and divide both sides by a 4. I can do that because the right side is 0. That just gives me x squared minus 16x minus 10 is equal to 0. And I paused this video because I had a blonde moment. Yes, I used to be a blonde a long time ago. Here I am touting all the advantages of not using calculators. And when I double check this, I get 252 and not 152. So this, bang, this has to be 252, which means that this is 252, which means that this is actually 60, positive 60. And when I divide both sides by 4, I get plus 15. Whew, okay, now that factors. I know, you guys are swearing at me because this is wasting time, but get over it. We have x minus 15 and x minus 1 is equal to 0. First outer inner last, that gets you negative 15, so x equals 15 or x equals 1. Okay, got our answer, but we got to interpret it. Only one of these makes sense. If I were to take this x equals 15 and plug it back into one of these two, oops, sorry. If I were to take it and plug it back into one of these two, I'd get a negative number. That would be 18 minus 30. The width up here would be 14 minus 30. Both of those would be negative. Now, a negative times a negative is a positive, but your side lengths can't be negative. Another way to think of this is the question is saying, what is the width of the frame? Well, that should be a pretty small width. I've never really heard of a 15-inch width, but I have heard of a 1-inch width. This would be 1 inch. This is small, which is good. Small, good. So we cancel that out, or cross that out. 15 will not work because it makes negative side lengths. So the question just wants to know what is the width of the frame, so we can say the width is 1 inch. Actually, I should probably say the width of the frame, because the width is, that can be confusing. The width of the frame is 1 inch. That's better. Okay, next one. A photograph. Always a photograph. 11 by 14 inches. Let's draw a photo. Let's draw a nice landscape with a tree. And grass. We have two grass. Okay. Photograph is 11 by 14. That's 11 by 14. A frame of uniform width is placed around the photograph. So I'm going to draw a big frame so we can write stuff in it. Find the width of the frame. Oh, the area of the frame is 150 inches. This is actually a little bit of a different problem. Just a little bit. It's kind of like the first one. I know that I'm going to have 11 plus 2x and 14 plus 2x for my outside dimensions because I'm going to have a width of x all around the border. Okay? Then, let's actually do that. So, we're going to do 11 plus 2x times 14 plus 2x. And the question is, what is that equal to? Well, here's the problem. I don't necessarily know what it's equal to because I don't know what the area of the whole thing is. Except it says that the area of the frame is 150. Okay. What is the area of the picture? Well, the area of the picture is this. This is the area of the picture. We'll say area of photo. And this is the area of the frame. And this right here is the total area. So total area equals area of the photo, 11 by 14, plus area of the frame is 150. So we got some simplifying work to do. 14 times 11. 14 times 11 is 154. Let me check that really. Yep, 154. And first, then outer plus 22. Inner would be plus 28. So this is 22 plus 28 is 50. X plus 40x squared equals, that is 154 plus 150. Well, these go away because if I subtract 154 from both sides, that's gone. Move everything over to the left side, and I have 4x squared plus 50x minus 150 equals 0. I can't divide both sides by a 4, but I can divide both sides by a 2. 2x squared plus 25x minus 75 is equal to 0. That's factoring out a 2 and then dividing it by both sides to actually get rid of it. So we want to factor now. I know the 2x has to be 2x squared has to be 2x and x. And 75 is made up of 25 and 3. It's also made up of 15 and a 5. And one of those has to get multiplied by a 2. So if I do 15 times 2, I get 30. Then we want to make that a positive 30 minus 5. And that's going to factor. Okay, so I have x is equal to, well, let me do steps. 2x minus 5 equals 0. 2x is equal to 5. X is equal to 5 halves. Which, since we're talking about dimensions of something, I'm going to write as 2.5. I know, it's okay this time because this is actually a life example. Then when this is x is equal to negative 15, which is out because it's a negative number. So x is equal to 2.5. That makes sense in terms of whatever this is. It's inches. So it wants to know what's the width of the frame. The width of the frame is 2.5 inches. Okay, last one. Originally, the dimensions of a rectangle were 12 by 7. When both dimensions were decreased by the same amount, the area of the rectangle decreased by 34 square centimeters. Find the dimensions of the new rectangle. This is kind of like a border problem, but it says when both dimensions were decreased by the same amount. So we can actually just say, let x equal amount decreased. And then I can actually go ahead and say, well, the new rectangle, that's a terrible rectangle, is, oh, come on, 12 minus x, and this is 7 minus x. And then we'll do an old rectangle in a different color. I know it's not to scale, but then this is 12, and this is 7. And we'll call this the old one. Now, this is different because I'm not drawing this as a border problem. They're not surrounding the other, so I'm not looking for like a width of the border. It's just looking for how much they're decreased by. So now it says the area decreases by 34 square centimeters. So that means the area of the old equals the area of the new minus 34. Or sorry, plus, my bad, other way around. Area of the old equals the area of the new plus 34. Yeah, when both dimensions are decreased, the area gets smaller. So that means the new area is smaller, so you'd have to add 34 to get back to the old area. Area of the old is 12 times 7. Area of the new is 12 minus x times 7 minus x, and then plus 34. Okay, 12 times 7 is 84. That's equal to 84. First outer, inner last, so 84 minus 19x plus x squared plus 34. Once again, the 84's actually drop out, and you have 0 equals x squared minus 19x plus 34. That can factor into x and 17 and 2 and minus and minus. I get x equals 17 and x equals 2. It wants to know the dimensions of the new rectangle. Well, if I plug 17 into either of these, I'm going to get a negative number. So that means that 17 is out. But if I plug 2 in, that works. Plugging 2 in gives me a new rectangle of 10 by 5, 12 minus 2 and 7 minus 2. So we can say the new rectangle is 10 by 5 centimeters. Done.